מדבר עברית לטוב, so I will speak English this time. So my name is Konstantin Belenki from Cyberint, and I'm going to talk about reusability in Redux applications. Before I start, I want to share with you the need which pushed us to think about reusability in Redux. This is a screenshot of our system. It's Argus that developed in Cyberint in order to make cybersecurity analysts' life easier. Just some numbers, about 20,000 of lines of JavaScript without testing, without anything. I mean, it's not counted. So I would say it's a middle-sized application. Once your application is becoming middle-sized, you need to think about reusability a lot in order to keep it maintainable and extendable. The most interesting thing that we implemented in our application is the tabs functionality. So tabs, actually you can open any page in the tab, and it should store the state of the tab separately, independently from other tabs, in order to let user to navigate back and forth. Okay, so we are going to reuse. What we are going to reuse? What is the Redux? Redux, in fact, is just a store. It's just a store, and we have an actions as an input for the store, and we have a primary logic of generating the output of the store is located inside reducers that we are placing inside the store as part of initialization of the store. So we are going to talk about code reusability in these three parts of Redux. It's an actions, reducers, and the store itself. But first, I want to introduce one more term. It's a high-order function. High-order function is a function which accepts at least one function and returns one function as a result. If your high-order function accepts one function and produces one function with the same signature, then you get, I would say, the simplest high-order function. Everything is returned, the same signature in the input, in the output. We are going to talk about only this simple case of high-order function. So your function is becoming composable, which means that you can apply such a function consequently in a way when output of previous function will be input of the next one. And since they do not change their signature, the resulting function will have the same signature in the end. In the second layer, you see how it's written in JavaScript. We are using compose function that can be found in every functional utilities library, or even in the regular ones, I would say. Like in Lodash, it's how it's called in Lodash? Anyone remembers? Never mind. So in fact, we can present our sequence of composed functions as a steps how we enhance initial functionality. So in this slide, you can correlate. So each step of this origami symbolizes one more applied higher order function in composition. Like every step in this instruction makes simple piece of paper be bored in the end. In the middle-sized applications, actions become more and more complex, with a lot of meta information which other models rely on. In this example, it's action which needs to trigger call of API method, fetch items with the parameters like which folder and which sorting, and in which tab this action occurs, and also in which place in the UI this action is relates. Imagine that you have hundreds of such actions and you need to refactor it. So you need to go all over there and to replace, so it will be quite painful. Let's start from bare minimum. Let's imagine that we have the simplest case when everything is simple. On the one place when we have fetching items functionality, on the one asynchronous action, on the one API method. So this is the action that we would need. Very expressive and very easy to understand what it does. And then we start enabling stuff separately using higher order functions. I would say higher order action creators. So first we show that this action is actually asynchronous action, which invokes fetch items API method. So we change the type of the action to the API request to indicate that it's asynchronous API request, and we add which method and which initial action type it was. I know that most of you like code more than everything else, so let me provide how this high order action creator can be implemented. First of all, we accept initial action creator as a first argument, and then and when it's time to invoke the action creator, when it's time to invoke this action creator, we invoke basic action creator and tune it up. So the result of this whole action creator will be slightly modified by us, like enhanced. Okay, let's go further. So let's add information about which tab this action occurs, and which place this action has been triggered from which place. And if you apply all these high order action creators at once, as output of resulting function, we'll have this complete object that we want. Of course, we are not reusing here anything. Like we have action that adds tab ID, the exact tab ID, and the exact place, and the exact API method. Of course, we want it to be reusable. So in order to do it, to make it reusable, we need to make it configurable, so we can use it in any place that we want. So we have more generic stuff, not related to specific tab, specific place, or whatever specific. So to make it configurable, we make Fabric to generate high order action creators. And via this Fabric, we set up our high order action creators. So if you have any question as I go, just don't hesitate or something. Okay, so this is what we will have in the end. On the left side, you see the initial action creator, which express the main purpose of the section. And on the right, it's a resulting action creator, which will be used in the application. And as you can see, it's quite readable. So you can see that this section uses API method fetch items. Its action creator is about some tab and about some place that can be configurable as well. So this is how we can reuse code in action creators using composition of high order action creators. Another Redux part is reducer. Here's an example of reducer of counter. So we have only two cases, only two actions: to increment the state and to reset state to initial. In order to reuse this reducer, even if logic will be totally the same, but we just need to reuse it in another place, we still will need to change it because we are going to work with other actions. So we are going to copy paste it and change just action types? I don't think so. So we are going to write factory one more time. Factory for reducers to be able to configure producing reducers. I prefer using distracting assignments of parameters handle them. So when you are using this fabric, it will be more readable which parameters you pass into it and which parameters corresponds to which settings. Okay, so we introduced this factory for making our reducers, and then we use it. We can use it in each place that we need to use our counter. Here is the example of using combined reducers, helper from Redux, in order to use counter reducer independently in header and in sidebar. So on the right, you can see how our state tree will look like in Redux. So reducers will manage independent part of the state. Let's look at another reducer. You can say that, okay, so let's look first. So this three actions. First is to set the state from payload of some action. Second is reset state to initial one. And third is just toggle the state. Actually, you can say that these three trivial cases is pretty famous along your application if you are doing it with Redux. So if it would be really great if you can just organize code in reusable pieces for these three cases and just use these reusable pieces. But in fact, reuse parts of the reducer is more problematic than reuse whole reducer. So in this particular case, these parts is just the cases. Of course, in these trivial, I would say trivial cases, it can be much more sophisticated logic. So the goal is to find the way how to organize our code in pieces, and then we can put them together and build the resulting reducer that we want, that collect all the functionality that pieces have. First approach that can help us to achieve this goal is to use handle actions helper from Redux actions package. Handle actions can create reducer based on map of reducers keyed by action types. So actually we can organize our pieces in the separate maps of reducers, of handlers that is keyed by action types, and just merge it before we are going to use it, and pass it to the input of handle actions. Of course, in order to be able to configure everything, in order to reuse, we just create factory to create maps, and just invoke factories in order to, before we are going to merge the maps itself. Looks pretty fine, but this approach has at least two cons. First of all, we cannot combine pieces which handle same action types, because they will override each other in resulting map. And the second con is if logic in one of such a piece is triggered not only by a specific action type, but by some more complicated condition, we just cannot do it, because we just stick to the API of handle actions. Another approach is to organize pieces of logic in separate reducers and use reducers helper in order to combine them together. So reducers function gets reducers as arguments and apply them one by one, so each reducer will be invoked with action as one argument, and result of execution previous reducer as the second argument. Looks more flexible, right? Now pieces of logic are just applied one by one and cannot conflict with each other on subject of action type. Also, now trigger conditions of each piece of logic could be not so simple as checking the action type, but it can be anything that you can achieve with JavaScript. But even now we can do better. You may note that all of these three mini reducers do not need that some other piece of logic after them will modify the state. They can just get the result and return it. In fact, it would be nice if we could do such a thing. So we can even eliminate redundant checks, and our application will be more efficient. So that's where high-order reducers come into play. High-order reducers is the function that get reducer and provide reducer. Let's consider these three reducers. First one is just gets payload and that's it, and just return it. The second, pass undefined and some not expected action type to the basic reducer in order to get the initial state from it. As you remember, reducers must return initial state in order they cannot handle any action. The third reducer just toggle the state on particular action and just pass the resultant state to the basic reducer. So in fact, we have full control over execution of basic reducer. So we can decide if you want to proceed to basic reducer or not, and if you want, which arguments we are going to use, and what result after all of this we want to return. And as well as any higher order function that accepts only one function and produce function with the same signature, which is high order reducer, we can compose them. So we can combine them together with the compose function. Here the just example list of which high order reducers now you can find on NPM. So just for example, I will go over some of them. Redux payload, it just sets a state as payload on some specific actions. Redux reset reducer, reset your reducer to initial state on some conditions. Redux map state can give you ability to invoke the map function before passing state to reducer and after reducer done his work. So it's very helpful if you are going to reuse reducer on state subtree which is not prepared, I would say, for this reducer. Redux map action is the same, so it allows you to change the action in order to satisfy reducer needs. Redux ignore help you just to not react on some certain actions at all. Redux undo provide the history of your subtree in the state, and you can navigate back and forth on this history. But not of all high-order reducers that you can find on NPM are ready to use in composition, because some of them gets not only reducer as an input, but also some arguments that set up this high-order reducer. But there's no problem. We can always use carry function from any functional library that just change the signature. So it carries the function. So it make it from several arguments function to the sequence of the function. So you can apply arguments one by one. And also, you always can wrap your reducer with so we have, for example, high order reducer that accepts argument 1, 2, and reducer, and we want to make it composable. We can wrap in the function which first accepts arguments that is not reducer, and then return the function that accepts only reducer. So we can use it in composition like that. So we just set it up and then use it in composition. In Cybernet we also use our helper function to build composable high-order reducers called extend reducer. So at the top, you can see the signature of extend reducer. It accepts reducer and map of actions, and map of reducers keyed by action type, and produce reducer with the logic from this passed map of handlers. So in other words, it really extends functionality of reducers. Actually, it's mostly the same as combining reducers and handle actions, but as a result, you will have a high-order reducer which can be composed, which is different from reducers approach. And also, there is available carried version of the extend reducer helper. So it first gets the handlers and then gets the reducers. So if you have already prepared maps of reducers, you can just reuse them in the composition without any creation of new reducers, I don't know, in new files. And here is the piece of real code that we have in our application. So maybe you think it's not very readable, but let's go from top to the bottom and see what we can get. So first of all, we see that the state will be resetted on the action type initial load and on another action type, which is good knowledge. Secondly, we see that there is some condition that blocks a reducer to invoke further logic. So if meta of the action, if the key inside meta of the action will not be equal some settings, that we just do not proceed to the further logic. Next line show us that we are going to use payload once we are going to use payload in our state if some certain action occurs. And the second two lines just shows us that this exactly reducer shares the functionality of creation entity and updation entity. You can see that it named blacklist entity reducer. So it's like logical to have all the functionality that basic entity has. And in the bottom we see block with I would say custom unique logic, unique for this reducer logic. So actually you can see that it's pretty readable, and you can see you can see from the beginning that you have two blocks with a custom logic and with some logic that repeated in some other places, and in fact you can read it. So this is how you can reuse quite efficiently code in your reducers. As we remember, beside reducers and actions, there is a store itself. Some of the tasks require the change of the way how store behave. For example, when some logic needs to be applied for all or for the most of actions, or maybe we want to persist application state in local storage, or maybe we want to integrate site storage of data so we can access it from rendering layer via Redux store API. So we can do it with the store enhancers. Let's consider how we use store in Redux applications. So first we import the create store. The create store is the function that with an input of reducer will create the store itself. And then we can just use the API of the store as we wish. And then we introduce store enhancer. What is it? The store enhancer is the function which gets the store creator function as input and return store creator function and as a result. So in fact it's a higher order store creator. Even more, it's a composable higher order store creator because it gets and produces the function with the same signature. So you can compose any store enhancer as you wish. In short, store enhancer has full control over the store. It can override any of the store method. It can alter results of any store method. It can even replace the store entirely. The most popular store enhancer that we are using is middlewares, which do no more than overriding original store API method dispatch. Let's see how apply middleware function is implemented, which is actually the factory of middleware. Never mind. So first of all, we pass the middlewares, the list of middlewares, to apply middleware function. Apply middleware is a function which produces store enhancers. So in fact, it's a factory to produce store enhancers. So we get our list of middlewares, and before we replace the original dispatch method with the enhanced one, and when some action occurs, first it gives middlewares ability to apply their logic based on action and the current state of application. So most popular middlewares do one thing. They enrich actions, which are plain objects by default in Redux. So for example, thunk middleware allows you to dispatch functions which will be invoked inside middleware with dispatch and get state method passed to it. So you can implement any logic, even asynchronous logic, inside this function that you pass to the middleware. And you can do inside middleware whatever you want with these two dispatch and get state methods. Another example of enriching actions is API middleware, which allows you to organize in one place logic of sending network requests instead of doing this in each place where we need to communicate with the server. So in particular, with this middleware application can dispatch action with some specific type, and this action will trigger the call to API method. And on the other hand, middleware will take care about dispatching pending or success and error actions to the application, to the store. So in fact, we encapsulated work with server inside one place, inside store. One more interesting usage of store enhancers is saving state in some other storage, like local session storage. This way we can persist state between page reloads or even between browser sessions. It is done by listening to changes in the store and saving state each time any change occurs in the store. On the other side, it passes the initial state once application starts. So the state of application when it starts will be the same as we leave it. Actually, you can do crazy things like developer tools which have ability to monitor and navigate through history of application state and even control these developer tools remotely. Or you can assemble your application state from many sources you have and communicate with these storages via Store API. So in short, you can change how Redux behave in any way you want using store enhancers, and you can use this power to achieve most dry code you wish. So thank you for your attention, and come and reuse code with us at Cyberink. We always hiring, as always.